You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is Cursor's real-time RL for Composer. AI code generation gets smarter. Here's a quick overview. Cursor introduces real-time reinforcement learning for Composer, enabling AI code generation that adapts and improves based on developer feedback in real time. Now, let's ask our analyst about these developments. What's new? Real-time reinforcement learning for Cursor Composer?
Cursor has launched real-time reinforcement learning capabilities for its Composer feature, fundamentally changing how AI code generation adapts to developer preferences. This update introduces a feedback loop system that allows Composer to learn from user interactions, code acceptance rates, and editing patterns in real time. Unlike traditional static AI models, this reinforcement learning implementation continuously refines its suggestions based on individual developer workflows and project-specific requirements. The system tracks which code suggestions developers accept, modify, or reject, using this data to improve future recommendations within the same coding session. The technical implementation leverages a lightweight RL agent that runs locally alongside Composer's existing language model infrastructure. This agent processes feedback signals including keystroke patterns, code retention rates, compilation success, and test outcomes to adjust suggestion parameters dynamically. The system maintains separate learning profiles for different programming languages, frameworks, and project types, ensuring that improvements in React development don't negatively impact Python data science workflows. Memory optimization ensures the RL agent operates without significant performance overhead, maintaining Cursor's responsive editing experience. Previously, Composer relied on pre-trained models with static behavior patterns that couldn't adapt to individual coding styles or project-specific conventions. Developers often found themselves repeatedly correcting similar issues or manually adjusting suggestions to match their preferred patterns. The new real-time RL system addresses these limitations by creating personalized adaptation profiles that evolve with each coding session, reducing the need for manual corrections and improving code suggestion relevance over time. Real-time feedback processing that adjusts suggestions within the same coding session, separate learning profiles for different languages, frameworks, and project types local RL agent implementation that maintains privacy and reduces latency integration with compilation results and test outcomes for comprehensive feedback, memory efficient design that operates without performance degradation.
Thank you for that analysis. Let's move on. Who benefits from real-time RL Composer updates?
Senior developers working on large code bases with established patterns will see the most immediate benefits from real-time RL in Composer. Teams maintaining legacy systems or working with domain specific frameworks often struggle with AI suggestions that don't align with existing architectural decisions or coding conventions. The RL system learns these patterns quickly, adapting to project specific naming conventions, error handling approaches, and architectural patterns. Development teams of 515 engineers working on shared code bases will particularly benefit as the system can learn from collective feedback patterns across team members. Full stack developers juggling multiple programming languages and frameworks throughout their workday represent another key beneficiary group. The system's ability to maintain separate learning profiles means improvements in front end React work won't interfere with back end Python API development. Freelance developers and consultants working across diverse client projects will appreciate how quickly the system adapts to new code bases and client specific requirements. Data scientists and ML engineers working with specialized libraries and domain specific patterns will find the adaptive suggestions more relevant than generic AI code completion. Developers working primarily with well documented, mainstream frameworks may see limited immediate benefits, as existing composer suggestions are already well optimized for common patterns. Teams just starting new projects without established conventions might not provide enough feedback data for meaningful adaptation in early development phases. Individual developers working on simple scripts or proof of concept projects may not generate sufficient interaction data to trigger significant RL improvements. Senior developers maintaining large code bases with established architectural patterns, development teams of 515 engineers working on shared, complex projects, full stack developers switching between multiple languages and frameworks, daily consultants, and freelancers adapting to diverse client code bases and requirements, data scientists working with specialized libraries and domain specific patterns.
Great insight, really helpful context. How to get started. Step-by-step RL Composer setup.
Before enabling real-time RL for Composer, ensure you're running Cursor version 0.42 or later and have an active Cursor Pro subscription. The RL system requires local processing capabilities, so verify your system has at least 8 GB RAM and 2 GB available disk space for the learning model cache. Open cursor settings and navigate to the Composer section. Then locate the real-time learning toggle. Enable the feature and select your preferred learning aggressiveness level. Conservative for gradual adaptation, balanced for standard learning rates, or aggressive for rapid adaptation to feedback patterns. Configure language-specific learning profiles by accessing the Learning Profiles subsection within Composer settings. Create separate profiles for each primary language or framework you use regularly. This prevents cross-contamination between different coding paradigms. For each profile, set the minimum feedback threshold recommended, 10 interactions before adaptation begins, and specify whether to include compilation results and test outcomes in the feedback loop. Enable team learning if working in a collaborative environment where multiple developers contribute to the same codebase. Verify the RL system is functioning by opening a project and using Composer to generate code suggestions. The interface displays a small learning indicator when the RL agent is processing feedback. Accept, modify, or reject suggestions normally. The system automatically captures these interactions. Monitor the learning dashboard in cursor settings to track adaptation progress, view feedback statistics, and adjust learning parameters. The dashboard shows suggestion acceptance rates, common modification patterns, and learning velocity across different project contexts. Update to cursor version 0.42 plus and verify 8 GB RAM and 2 GB disk space availability. Enable real-time learning in Composer settings with appropriate aggressiveness level. Create separate learning profiles for each primary language and framework. Configure feedback thresholds and enable team learning for collaborative environments. Monitor learning dashboard to track adaptation progress and adjust parameters. Use normal Composer workflow. The system automatically captures feedback signals.
That's a very interesting point. Tell us about competitive context, how real-time RL changes code generation.
GitHub Copilot and Amazon Code Whisperer rely on large-scale pre-training without real-time adaptation capabilities, making Cursor's RL implementation a significant differentiator. While Copilot excels at generating code for common patterns found in public repositories, it cannot adapt to proprietary coding standards or project-specific architectural decisions. Code Whisperer offers some customization through enterprise fine-tuning, but this requires significant setup overhead and doesn't provide session-level adaptation. Cursor's real-time RL bridges this gap by offering immediate personalization without requiring custom model training or enterprise-level configuration. The adaptive learning capability creates specific advantages in enterprise environments where coding standards and architectural patterns differ significantly from open-source conventions. Traditional AI coding assistants often suggest public repository patterns that violate internal security policies or architectural guidelines. Cursor's RL system learns these constraints quickly, reducing compliance issues and code review overhead. The local processing approach also addresses privacy concerns that prevent many enterprises from using cloud-based AI coding tools, as sensitive code patterns never leave the development environment. However, the RL system introduces complexity that may not suit all development scenarios. The learning process requires consistent feedback to be effective, making it less suitable for developers who rarely accept AI suggestions or work primarily on one-off scripts. The local processing requirements also create hardware dependencies that cloud-based alternatives avoid. Additionally, the system's effectiveness depends on the quality and consistency of developer feedback, which can vary significantly across team members and development phases. Real-time adaptation versus static pre-trained models in Copilot and Code Whisperer local processing addresses enterprise privacy concerns with sensitive code bases, immediate personalization without requiring custom model training or setup overhead, superior performance with proprietary patterns and internal coding standards, hardware requirements, and feedback dependency limitations compared to cloud alternatives.
Good analysis. Let's continue. What's next? Future implications for AI-assisted development?
Cursor's roadmap indicates expansion of RL capabilities beyond code generation to include debugging assistance, refactoring suggestions, and architectural recommendations. The company is developing cross-session learning persistence, allowing the RL system to maintain learned preferences across cursor restarts and system updates. Integration with version control systems will enable the RL agent to learn from code review feedback and merge request patterns, incorporating team-wide quality standards into individual suggestion algorithms. Advanced analytics features will provide development teams with insights into coding pattern evolution and productivity improvements attributed to RL adaptation. The broader ecosystem implications suggest a shift toward personalized development environments where AI tools adapt to individual and team preferences rather than providing generic assistance. Integration partnerships with popular development frameworks and testing tools will expand the feedback signals available to the RL system, creating more comprehensive learning opportunities. The success of Cursor's approach will likely influence other AI coding tools to implement similar adaptive capabilities, potentially leading to an industry-wide movement toward personalized AI development assistance. Long-term prospects include the development of collaborative RL networks where teams can share learned patterns while maintaining code privacy, and integration with continuous integration pipelines to incorporate production performance data into the learning feedback loop. The evolution toward more sophisticated adaptation algorithms will enable AI coding assistants to understand not just what code to generate, but when and how to present suggestions for maximum developer productivity and code quality outcomes. Cross-session learning persistence and version control integration planned for 2024 expansion to debugging, refactoring, and architectural recommendation capabilities industry shift toward personalized AI development environments and adaptive tooling collaborative RL networks for team-wide pattern sharing while maintaining privacy integration with CI/CD pipelines for production performance feedback incorporation.
Great analysis. So, what are the key takeaways from all of this?
Enable real-time RL in Cursor Composer settings with separate profiles for each programming language to maximize adaptation effectiveness. Monitor the learning dashboard weekly to adjust aggressiveness levels and feedback thresholds based on suggestion acceptance rates. Configure team learning for collaborative projects to leverage collective feedback patterns across multiple developers. Maintain consistent feedback patterns by regularly accepting, modifying, or rejecting suggestions rather than ignoring them.
And what market signals should our listeners watch for?
Personalized AI development tools. Cursor's real-time RL implementation signals a market shift from generic AI coding assistants toward personalized development environments. This trend reflects growing enterprise demand for AI tools that adapt to proprietary coding standards and architectural patterns rather than suggesting open source conventions. The success of adaptive learning in code generation will likely drive similar implementations across development tool vendors, creating competitive pressure for personalization capabilities. Local AI processing adoption. The local RL agent approach addresses enterprise privacy concerns while maintaining responsiveness, indicating growing market preference for hybrid AI architectures. This signals reduced reliance on cloud-only AI services in favor of solutions that process sensitive code locally while leveraging cloud capabilities for model updates. The trend suggests increased investment in edge AI processing capabilities across development tool providers. Feedback-driven AI improvement. Real-time learning from developer interactions represents a fundamental shift from static AI models toward dynamic, feedback-driven systems. This approach creates sustainable competitive advantages through continuous improvement and user lock-in effects as the system becomes more valuable with increased usage. The market will likely see increased focus on user interaction design and feedback loop optimization across AI development tools.
What should developers and operators do with this information?
Enable real-time RL immediately if working on established code bases with 500 plus files and consistent coding patterns. Wait 2 to 4 weeks before enabling RL on new projects to establish baseline coding patterns and architectural decisions. Configure aggressive learning settings when onboarding to new client projects or unfamiliar frameworks for rapid adaptation. Disable RL temporarily during major refactoring efforts to prevent learning from transitional code patterns.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.